So question 2, we've got our differential equation here, and we've got a quadratic on the end there. And it's actually asking us to find the particular integral first. So that's when we go for let y equal, now as it's a quadratic, we're going to go for lambda plus mu x plus nu x squared. We differentiate that, and we just get the mu there and the 2 nu there. And we differentiate it again, and that just leaves us with the 2 nu at the end there. Substitute all of that into the big long quadratic here. Means for the first bit there, we've just got 2 nu minus 5 mu minus 10 nu x, and it's plus 4 of these ones here, of the y ones. So 4 lambdas plus 4 mu x's plus 4 nu x squareds. And that equals x squared minus 3x plus 2. Now, as usual, I can probably spot that nu, which is the number of x squareds here, is just going to be a quarter, but I like to try and use the simultaneous equation solver to do it. So what we're looking for, first of all, we're looking for the x squareds, and we've got lambda, mu, and nu. So no x squareds for any of those. We've got 4 of them there, and we know that wants to equal 1. Now let's look at the x's, and we know there's no lambda x's, but there are some mu x's. There's 4 of them. And then how many x's here? We've got minus 10 nu of them there, and the x's we want minus 3. And now this row here is for the constants. First of all, the lambdas, which is 4 of them, then the mu's, which is minus 5 of them, and finally the nu's, which is 2 of them. And for the constant, we want that equal 2. And so it gives us lambda is minus 7/16, mu is minus 3/4, and now we know that's wrong, don't we? It's because I put a 1 there, I put a 0 there instead of a 1. Whoa. So it's lucky we did that little check, isn't it? So we can now spot that I've got that wrong. And sometimes I'd redo a video there, but it's good to see that that's why I would do that little mental check to see what it was going to be. So lambda is 7/32, and mu is minus 1/8. And look, that's why we did the check. And nu is 1/4. So the particular integral is going to be 1/4 x squared minus 1/8 x plus 7/32. So part B is just to then to work out this side here as well. So our auxiliary equation is m squared minus 5m plus 4 equals 0. That solves to give m is 1 and m is 4 using a quadratic solver. And so the actual answer is a e to the x from that part, b e to the 4x from that part, plus all of that stuff there at the end there. So sorry about the mistake, but at least you spotted me recover from the mistake there